Hi, this is Saranya Sheshalla. Welcome to ECP Tech. Today in this class we are going to learn about one of the main important topic of network layer is shortest path algorithm. Shortest path routing algorithm, right? So this is one type of routing algorithm. The network layer main responsibility is routing to find out the best route from source to destination, and we have a different type of algorithms to find a best route or a shortest path from source to destination. From source to destination. Let us get into the topic. What is the different type of shortest path algorithms we have, and what is the use? How can we travel, or how can we send our data packet from source to destination to find out a best route or shortest path? Right. So here, Dijkstra's algorithm. It is one of the most efficient shortest path algorithm. We can send data from source to destination by using a best route. Right. So here Dijkstra's algorithm is an greedy algorithm. Greedy algorithm, or we can call it as an iterative process algorithm. Iterative process algorithm. We have a source and destination. This is a single source shortest path. We have to find it from source node to different nodes, nothing but an we have to find the shortest path of each and every node that connected to the destination. We have a one type of network, right? So we have source and destination in between so many number of routers or nodes that pass our information from source to destination. So we have to find so which node has a shortest path, by which way we have to send our data packet from source to destination. We have to find the shortest path or an best route. So Dijkstra's algorithm find the shortest path from a particular node called the source node to every other node in a connected graph, means that connected to the network. So in one type of networks or different type of networks, we are passing one information or our data from source to destination. What are the different type of nodes that connected, that interlinked in between these networks? So we have to find that node's shortest path, and we have to choose one best route to send our information data from source to destination, right? So this Dijkstra's algorithm was introduced by a computer scientist Edgar W. Dijkstra. Edgar W. Dijkstra. So in the year 1956, for some reasons, it will be released or published 3 years later. In the 1959, this algorithm was released. Right. So here we have to find a shortest path by using this algorithm to generate an optimal routes. We have to we have to know what is an input and what is an output. So the input of an Dijkstra's algorithm is a graph representing the network, means source node. The output, the shortest path tree. So from root node to the destination, nothing but an shortest path from source node to destination node, the shortest path we have to find, that is an output. So let us take one example how we can find an best route by using a discrete algorithm. Okay, right? So we have to see an one example here. So let us take one example of a Dijkstra's algorithm to find out the shortest path. Here I am taking one graph to find a shortest distance from one node to another node. To find a shortest distance from one node to another node. For that I establish a shortest path from source to destination to deliver our packet in between these nodes. Right. So let us take one graph. Okay. So I'm taking one graph here. So this is an actual graph. So we have to find the distance of each and every node. We have to find the distance of each and every node. So we create an shortest path from source to destination, and from that path only we are sending or we have to send the data from source to destination by using these nodes. Let us find the distance between each and every node, right? So I'm taking an example here. So this is an cost by using cost. So let us get into the graph. We have to note two things here. D of x means the first vertex, D means Dijkstra. D of y means second vertex. Okay, so this is an one graph I am taking to find and distance between each and every node, right? So this is an sender or source vertex. This is an destination. This is an destination. So I have to send data from source to destination by using between these nodes. Between these nodes, right? So I have to find each and every node distance from a previous node. Each and every node distance from previous node. So I am writing this graph again here. So look at carefully. Right? 1 2 4, 2 2 5, 3 to 6. These are the connections, right? So we have to write a minimum cost. So each and every node we have a some particular cost here. So 0 to 1 we have a 4. That is a main graph. So 0 to 4 we have a 7. 1 to 2 8, 7, 11, 2. So this is an actual graph. So this is a source vertex, right? So what are the adjacent vertices? Means adjacent vertices means interlinked vertices or connected vertices. So from 0 to we have connected two vertices, that is 1 and 4. We have to find the minimum cost. By using that minimum cost only we will find and best route here, right? So from 1 4, right? This is an source vertex. So you have to draw a graph for each and every step while we are taking an minimum cost, finding and minimum cost and finding and minimum shortest route. We have to take for each and every step of one graph. So 4 and 7, right? So which one is the minimum cost? The 4 is the minimum cost. So we can we can establish route from 0 to 1. Source vertex to next node is 1. So here 4 comma 0 and 7 comma 0. 0 means the actual where that particular cost is coming from, means that is in the main the particular vertex. So 0 vertex and minimum cost of from 0 to 1 is 4, from 0 to 4 is 7, right? Okay, so we establish a path, we set a path from 0 to 1 because the one has a minimum cost, right? Next we can consider, next step means from 0 to 1 I set an path, I set one path, right? So we can consider the one is a source vertex to find out the remaining vertices distance, to find out the remaining vertices distance, right? Okay,
So each and every step we have to draw this graph. Just okay, these are the connected. So 4, 4 comma 0, 7 comma 0, 7. So from 1 we have a 2 vertices. 1 to 2, 1 to 4. The adjacent vertices are from 1, 1 to 2, 1 to 4. So right minimum cost is 8 and 11. So which one is short? 1 to 2 is an short 8 minimum cost. But here we have to observe, we have to add the second minimum cost with the previous thing. The second minimum cost with the previous thing means we are considering the next node as a source vertex, right? One is a source vertex, but here one already have a minimum cost of 4, right? We have to add that 4, 8 plus 4 is 12 comma 1. Okay, 11 plus 4 is 15 comma 1. So which one is an minimum? The 12 comma 1 is an minimum. So I have to set an path from 1 to 2. Here to find the distance of wherever we are finding a distance of an each and every vertex, we have to add that minimum cost with an previous node minimum cost, right? So next we can consider the second node as a source vertex. From 2 we are to find and what are the adjacent vertices here. So 2 to 5, 2 to 3, right? 2 to 5 and 2 to 3, right? So draw this diagram again. Graph. Draw this graph again. Okay. So this is a 4 comma 0. This is a 12 comma 1. So 2 to 3. Consider the first diagram. 2 to 3 we have a 7. 2 to 5 we have a 6. Right, that cost 7, 6. So add that previous one. 12 plus 7 means 19 comma 2. So 12 plus 7 means 18 comma 2. Right. So which one is an minimum? The 18 comma 2 is an minimum. Means we have to set a path from 2 to 5. So second vertex to fifth vertex. So I am setting an by using a minimum cost, I am setting an path from 0 vertex to 1, 1 to 2, 2 to 5, right? So now consider the 5 is an source vertex. Consider the 5 is an source vertex. So see the what are the different type of adjacent vertex from 5? There is only one adjacent vertex is 6. So write down minimum cost. So what is the minimum cost from 5 to 6? See 2. 2 is a minimum cost. So write that minimum cost. So add it to the previous one 20 comma 5. Okay. So we have to set a path from 5 to 6. Neatly draw the graph again. 0 to 1, 1 to 2, 2 to 3. Right. Sorry. So write down each and every node cost. So from 6 we have to find an okay next adjacent vertices. So we can consider the 6 is an source vertex to find and the next node distance. So we have only one node, that is 6 to 7. So right, see the cost 10. Write down here 10. Add to the previous one 30 comma 6. So this is an path we choose to send our data packets. So write down clearly 0 to 1. 4 comma 0 4 8. So we have to add to the previous one. So 6 18 comma 2, here 2 20 comma 5. From 6 this is the last destination. So this is a destination node. There is no links of this particular destination. So the path is 0 to 1 to 2 5 to 6 to 7. So this is the shortest path and the minimum cost we find by using this graph. By this way, we have to find the each and every node distance and each and every node cost. We have to consider the minimum cost of each and every node. So first we have to find the shortest path, means we have to see what is the source vertex and what are the different type of adjacent vertex from the source vertex. We have to identify that from that adjacent vertices which is a minimum cost. There is only one adjacent vertex, means we have to send directly. There is we can't choose and that where is the minimum cost here. So whenever one vertex contains two or more adjacent vertex, we have to see the cost. We have to see the cost of that vertex. So which one is a minimum, we have to choose that vertex that way and establish a path from that vertex. And this is a Dijkstra's algorithm, and it is very efficient algorithm to find the shortest path. Right, I hope you understand this. This is an actual shortest path we find by using this graph. Kindly like, share, subscribe EasyBTech for more videos and more problems. Right? Thank you.